Hello, you're right. Now that you've done your tests, you should use this next lesson to practice on your weaknesses. You may wish to go through all of the questions on the My Practice section, or you might want to identify a few of those questions. What I will do in this video is to give you a way to mark your work. Okay, so in question 1A, once you've done it, check this length here. And if you're getting something like 3.3 centimeters, then your construction's fine. In 1B, okay, so start with the 60 millimeters, the angle, and then the 50 millimeters. You should find the longest length is about 9.4 centimeters. When you come to C, perhaps you will start by doing 4.5 centimeters, measure an angle of 55 degrees, then we don't know how long this goes. So we need something else. So you should notice that we know that's 9 to here, so we need to find the missing angle here. Okay, so if you find the missing angle there, that gives you 35 degrees, and construct an angle of 35 degrees. You should find that to be 90 degrees. So measure and see if that's 90 degrees, and that should be fine. Okay, if you want to check again, this bit here, I'm making it to be about 3.6, 3.7 centimeters. So you should find that's about 3.7 centimeters. You're working for question 2 should look something like this. So you will start by either one of these lengths. So I've started with the 9 centimeters, and then I should see your pair of compasses opened up to 7 from this end, draw an arc, 4 from this end, draw an arc. Please keep these as working, don't rub them out. So if you want to check that you've done it correctly, if you measure this angle here, you should find this to be 48 degrees. Okay. For the second one, you should start with the 4 centimeters. So draw that first in any way, and then measure 90-degree angle, and then extend that line. Then we will need to open up your pair of compasses to 8.5 centimeters, and then put it on this end, and then you should then make an arc. Okay, and then draw the triangle. Okay, and if you want to check the accuracy of this one, so if you measure this length here, this side here, you should find that to be about 7.5 centimeters. Okay. In question 3, it says we've got equilateral triangles, so net made of equilateral triangles. So you want to pick a triangle to start with. So if I start with this one here, so we're not given any length, so you have to pick something. So 4 centimeters might be a sensible measurement. So start with that one, and then we're going to then construct another 4 centimeter line here and here. Okay, so 4 centimeters on here, and then 4 centimeters on here. Okay, and join them together. And then if you repeat this on above as well, so we can get this triangle here. So we do that next. So repeat it on this end, arc on both sides, and then join them together. And then we can just repeat this. Okay, so we just keep the size fixed as your starting measurement, and then keep going. So we can now draw that one here, and so I know that's 4 centimeters here. So if I extend that, and another 4 centimeters here, and then join them together. and that's the net completed. Okay, in 3B, essentially, if you notice that this part here is what we've got here. So if you just continue on drawing drawing these arcs, you should get there. Something like this. Notice that I've used a pair of compasses to start this off, but you could have also measured 60-degree angles here to help you construct that net as well. In question 4, so you're asked to start by constructing that, and you should notice first of all that these are the same lengths. So start by the 6 centimeters and then open up your compass to 8 centimeters, an arc on this side and this side, and join together. Then you're asked to join a perpendicular bisector of AB. So for this, open your compass to more than halfway and then go through your process. Arc above, arc below, same distance from B as well, arc above, arc below. Okay, and then join those two together. Okay, and then it says comment on your result. So what you should find is if you extend this line, the perpendicular bisector should basically divide the isosceles triangle exactly in half into 2 right-angled triangles. Okay, apologies about that. So if I move that bit top, so perpendicular bisector of AB goes through the apex of the triangle and it creates 2 identical right-angled triangles there. Question 5. So start with a diagram like this, and it says construct the perpendicular to the line through P. So open up your compass so that you'll pass through the line at 2 points, 2 places. So, and then make 2 cuts on the line as so, and then label those A and B, and then you're asked to do the perpendicular bisector of AB. So continue on like that, cut above and below, cut above and below. There is no need for these. You could have left this out, by the way, and then join them together. Okay. Okay. As you did that, you should you would have kept the same distance on your compass. You won't change it. So this should give you a clue that AP, BP, PP, BC, AC are all equal. So these are all identical. Okay. So if that's the case, okay, so this shape is called a rhombus. Okay. So one of the properties of a rhombus is that the diagonals, so that's PC and A to B, will always meet at right angles, and in particular, more importantly, it will actually bisect each other. Okay, so that this is the same length as this. Okay, so that's one of the properties of a rhombus. Okay, so maybe you should write something like that. Diagonals of a rhombus bisect each other at 90 degrees. Question 6, you asked for a scale drawing. You're told that the scale is 1 to 500. Okay, so all that means is everything on the scale is 500 times smaller than that is in real life. So here, so the 26 meters high change it to centimeters. If you divide by 500, then that will tell you how long and how tall it is on the scale. Likewise, 6 meters, change it to centimeters, divide by 500, you get 1.2 centimeters. So that's the scale you get. Then you're asked to estimate the height of the person in the photograph. Okay, so to do that, okay, so if you compare the photograph and the person, try and work out how many times taller the height is, so that we know the height is 26 meters. Okay, so the person we're trying to figure out, so how many of these people will, if you keep trying to put them on top of each other, will make up to 26 meters. Okay, you should find that you get about 10. Okay, so if you put 10 people top to top, okay, you get to 26 meters. Okay, so what that means is the height of the person in the photograph is going to be equal to 26 meters divided by 10, okay, which is equal to 2.6 meters. Let's think about that again. Well, that doesn't look correct, does it? So let's have a think about that again. You can't have somebody that tall, it's unrealistic. So I'll print another one. Okay, so this time, depending on what you've got, you might get a similar thing. So you've got the person here, it's quite fake, but that person there, okay, I've counted about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this is 17 times bigger than the height of the person. Okay, so I'm going to do here. So for that one, 26 meters divided by 17, which gives about 1.5 meters. Okay, which seems more realistic for the height of the person. So drawing that on the scale then, so you get something like 0.3 centimeters on your scale diagram for that one. Okay, so question 7, we have a scale factor of 1 to 50,000, so 50,000 times bigger. So if you multiply that by 50,000 and then change that to meters, then kilometers, you should find that a centimeter is represented by half a kilometer. Okay, so using that, you should get the following answers.